So we're going to do this on the same axis. Now that we have a natural scale, a normal one, we can graph easily 1/4 x. 1/4 x, we know it's a line. It has a y-intercept of 0. It goes up 1 and to the right 4. Or down 1 and left 4. So let's connect those dots. I'm going to put it in a dotted line just to make it look different. Now our cosine graph continues up like this, and on this side it'll go back down. So now, how many solutions are there for this equation? Cosine of x equals 1/4 x. How would you find them? Well, in terms of how many, we could look at our graph here. How many times do these two graphs intersect? They intersect once here, there, and there. So how many solutions? Number of solutions? We have our 3. How would you find them? What way do we have that can allow us to do this? Remember, I had you write down a statement back in chapter 5, and it said whenever you're dealing with a exponential, log, trig function, and a polynomial in the same equation, you cannot solve it by hand. We do not have that knowledge. So what do we use? Our graphing calculator. So right down here, how would you find them? Using the graphing calculator with the second intersect. When we do this, the second calc, and then we go to the intersection on our calculator. So write that down. So using graphing calculators, use second calc intersection. All right. Next one. Latitude. Latitude is the degree measure of the shortest arc from that point to the equator. If the city's latitude is 36 degrees north, how far is it from the North Pole? We're going to use the Earth radius as 3,963 miles. So let's sketch a picture. How do you sketch a picture? We're talking about the Earth here. How do you like my Earth? I'm just kidding. That's not all it. So let's actually make it look three-dimensional. So what we'll do is we'll put an ellipse here, and then we put it dotted in back. Now does that look like a sphere? That's not half bad. We're going to start in the center. Now it says it's 36 degrees north, so we're going to go shortest arc from that point to the equator. We'll start, here's the equator, and we'll go 36 degrees north of the equator. If it said south, we would go down. So this point there would be 36 degrees north. This measure would be 36, so that means the inside part, it's a central angle, would be 36 degrees. Now I want to say how far it is from the North Pole. The North Pole is due north. We'll come up there, and if this is 36, how am I going to calculate that angle? Well, that angle will be 90 minus 36, so it'll be 54 degrees. And what do I want to find? How far it is. How far is it? I want to find the length of that. Recall we've already done problems of length. So we would say 54 degrees is to 360 degrees, sorry, as the length, let's just call it L, is to the entire length of this circle. And what would that be? That would be r 2 pi r. So we would have 2 pi times 3,963 miles. So let's solve for that. Now let's take a look and see what this is. Another way, and I've done when I dealt with arc length before, there's multiple ways that you can look at it. This is saying what portion, what fraction of the entire arc do we want? And the entire arc would be the circumference here. And at this point, you just take your calculator out and do 54 divided by 360 times 2 pi times 3963, and you get approximately 3735.03. That's probably a little too much detail, so let's just give 3735 miles. Let's go on to the next page. The latitude of city A is 36 degrees 6 minutes north, and B is 30 degrees north. So how would we go about doing this? Let's sketch a picture again. We have a circle. We'll draw an ellipse in the middle, make the backside dotted. So we're going to go from the horizontal, from the equator, we're going to go up 30 degrees. That's city B. And I'm going to make it a little exaggerated just so I can see it clearly. And this would be city A at 36.6. Now, what do I really want to find? I want to find this angle in between. I'll call that one theta. Well, theta is going to equal our 36 degrees 6 minutes minus 30 degrees, so we get 6 degrees 6 minutes. And at this point, we'll set it up just the way we did before. The only difference between this one and the last one is now we had to do the subtraction to find this, but we have this 6 minutes. We're going to need to convert that to degrees. So what would that be? 6 minutes times 1 degree over 60 minutes using our railroad track stuff. So we reduce that out and we get 1/10 of a degree, or in other words, just 0.1. 0.1. So this is equal to 6.1 degrees. Now we have L is 2 pi divided by 3963 miles equals 6.1 degrees over 360 degrees, which is equivalent to saying what portion of the entire circumference do we want. Type that in on your calculator and we get about 421.92 miles. So we'll go with 422. Again, on this one, it's just for the accuracy. The accuracy part is not a big deal. I'm not focusing on that. I will probably tell you if it's a quiz or a test, go to a certain number of decimal places. Typically, we'll just go to 2. All right, we have Earth's rotational speed at a city is the circumference of the circle the city travels divided by 24 hours in miles per hour. Okay, that's going to give it to us in miles per hour because we're going to find the distance traveled in miles. Okay. What is the Earth's rotational speed at Bangor, Maine? It has a latitude of 45 degrees north. So how am I going to go about doing that? If I set my picture up again, and I go from the center, I go up to 45 degrees, this is traveling at the circle that it's on is just going around here. Now I know that the distance from the center to that point is going to be 3963. That's the radius of the Earth approximately. And what do I want to find? In order to find the amount of travel here, that's basically the circumference of this circle. So I need to find R. And I can drop this down and I have a right angle there. So what do I have? I can say, and I know that this bottom piece is 45, and if that's 45, that means the upper piece is 45 because it forms a right angle, a 90-degree angle. So what can I say here? I can say, dealing with this angle and the R, I can say the sine of 45 degrees equals the opposite over 3963. This is one way to do it, given that, and I want to show it, it's a little bit more general, but given that it's a 45, we could use the special right triangle ideas. Now, what is the sine of 45 degrees? We know that's square root of 2 over 2. And we're going to multiply both sides by 3963. So we'll have 3963 times the square root of 2 over 2. And that's going to be my radius. And that is approximately 2,802.26 miles. Now, we don't want to just use this number here. What we want to use is the entire number, whatever number is in on our calculator. So when I look at that, I'll kind of put this here. The real number is actually 26417 for the decimal places there. We need to keep those all on the calculator when we do this calculation. So now we need to find the circumference. The circumference equals 2 pi r. So that's 2 pi times. We can just write down 2,802.26, but we'll keep all those decimal places when we do the multiplication. And this time it'll be 0.5. Let's see if you can see that there. So I took my answer times 2 pi, and I get 17,607.145. So I round that up. So now what does it say that we're going to do? Our speed will equal that distance, 17,607.15. Again, I'm going to just use the whole number on the calculator, and we're going to divide it by, this is miles, we'll divide it by hours. And we get approximately, divided by 24, so we'll get 733.63 miles per hour. Or about 734 miles per hour. The last one is very similar, except this time you are going to be dealing with in the southern hemisphere. So it's going 30 degrees south, and we will have its circle something like this. We'll have a radius here. Now, there's a couple ways we can do it. We could also, let me show a different way on this one. Instead of using this piece here, what I could use is taking at this point and going up. So I basically have a rectangle here where this piece is R. And again, I know my radius is 3963. So this time what I could say is the cosine of 30 degrees equals the adjacent R over 3963. If I did it like I did the first one, this would be 60 degrees, so I would say the sine of 60 degrees equals opposite over the hypotenuse. Now we know the cosine of 30 degrees is square root of 3 over 2 times 3963, and that equals R. So let's type that in, 3963 times square root of 3 over 2, and we get 3432.06 is about equal to R. Now, we could just skip straight to speed, because all we're going to do is do 2 pi times that value and divide it by 24. So if you want, we can reduce this so to make our calculation a little bit simpler. So we'll take that value and multiply it by that we have on our calculator, multiply it by pi, and then divide by 12. And we get approximately equal to 898.51 miles per hour, or 899 miles per hour. And that's it.